Hi, welcome back to iRender. Today we're exploring the fascinating concept of pursuit curves. A pursuit curve represents the path of an object as it chases another. In mathematics, when endpoints m1, m2, mn, traditionally flies, mice, ladybirds, chase one another each at a constant speed, with mk chasing +1 and mn chasing m1, the trajectories of these points are mutual pursuit curves. For all regular polygons, each point traces out a logarithmic spiral pursuit curve, with all trajectories eventually converging at the center. This concept involves many complex formulas and mathematics knowledge. You can dive deep in if interested. But in this tutorial, luckily, we won't be diving into heavy calculus. We'll share how to recreate these mutual pursuit curves in 2D and 3D using the scene nodes in Cinema 4D. Let's get started. To set up 2D pursuit curves, we'll begin with the object group. You can also use node spline. Use the n-side node to change the number of sides as needed. Set the sides to 3 to create a simple triangle as our starting shape. Next, use a geometry property get node and set the type to positions. We get array of the triangle's vertex positions. Our goal is to have each vertex chase the next at a constant speed. For example, A will chase B, B will chase C, and C will chase A, all simultaneously. To achieve this, use the loop carried value node. Connect the array port to the type of port to identify the data, then connect the array port to the variable 1 port of the loop carried value node. We can delete the data type node we just created. Inside this loop carried value node, add an iterate collection node connected to variable 1 port. Create a get element node. Change data type to array containing vector. Duplicate the node and connect both to variable 1 port. Link the index port of iterate collection to the first get element node's index port. Now, add an arithmetic node, set data type as int, operation to subtract, and input 2 as 1. Connect port, index to input 1, result to index of the second get element node. This gives us the position of any vertex and its adjacent vertex of the triangle. Connect their value to an arithmetic node, select data type as vector, operation as subtract. Then we will have a direction vector between two adjacent points. To make the points move at a constant speed, connect to a normalize node, and finally connect to the direction port of the alignment node, setting orientation of y-axis as 1. To make each vertex move toward its adjacent vertex, use a mix node with vector data type. Combine the vectors from the alignment and mix nodes. Use the assemble collection node with the scope received from the iterate collection node to collect results. Create a parametric control from the blend port of the mix node. The loop carried value node needs scope. Create it from a range node. Temporarily set it to 5. Use append elements to gather results from the loop carried value. Add an assemble spline to check your results. Set the spline type to linear. As you increase the progress value, the triangle vertices will chase each other, spiraling toward the center. Adjust the number of polygon sides to explore other shapes. To track all moving points, use a memory node. Inside this node, use append elements and iterate collection to record data. Adjust progress and keyframe it to see the curves evolve. You can also control rotation direction clockwise or counterclockwise by modifying the operation port of the subtract node in loop carried value. Change parameters to explore different polygons and patterns. If we don't use the pattern but just pursuit curves, adjust it in the memory node. Now we've completed our mutual pursuit curves in 2D. To create mutual pursuit curves in 3D, we need some adjustments. Start by adding a platonic object for flexible 3D shapes. Set its type to tetra as the simplest form. Connect it to a subdivide node. Initially set the subdivisions to 0. Connect this to a polygon's info node. Use an iterate collection node to gather data from positions port. Link collected data to the loop carried value node. Change the scene frame to check the result. Try out different platonic types and adjust the subdivisions until you are satisfied. And that's it. We've recreated mutual pursuit curves in both 2D and 3D with the help of Cinema 4D's scene nodes. If you enjoyed this tutorial, don't forget to like, subscribe, and stay updated on the latest tutorials from iRender. Keep exploring, keep creating, and as always, happy rendering.